Hi, hello. Hello, people. People from YouTube and Instagram. In Instagram, I'm just going to try to show the best I can, even that is not possible. We're gonna work on questions of 3D shapes, basic questions of 3D shapes, and I just want to verify that everything is correct. Yes, everything is correct here. Hello for the people that are connected here. We're going to work a little bit with geometry, 3D shapes, answering questions about 3D shapes. This is going to be something of about 20 minutes. I'm just going to take 20 minutes to do the best I can. If you cannot see it in Instagram properly, I suggest you to go to YouTube because it's easier. I'm just going to post in Instagram a few information and maybe you're going to listen some ideas. And we're going to start now with our questions to be working today. First, we're going to identify faces, edges, and vertices of 3D shapes. Something very quickly. The first question says that June states that she can create a 3D shape with 6 faces and 12 vertices. And we want to know if she's correct. We're going to talk about 3D shapes. We have this shape with 6 faces and 12 vertices. And what you need to think is which shape could have 6 faces. So for example, the first shape that we can have with 6 vertices is a... Okay, I'm having problems here to write. The first shape that can have 6 faces is could be a pyramid or a prism. Okay, any of these two, maybe it's gonna have the 6 faces. So 6 faces and 12 vertices is going to be, for example, a rectangular prism. It's not working, my pad. Give me a second to see why this thing is not working. A minute, please. A minute, please. Now it's working. Okay, so the first idea is that we have 6 faces and 12 vertices. Is it possible to have a shape, a 3D shape with 6 faces and 12 vertices? One shape with 6 faces could be a pentagonal pyramid. So if you imagine a pentagon, 5 sides, and then here the vertex, and we join them. So we're gonna have a pentagonal pyramid. The pentagonal pyramid is going to have 6 faces. The face that is in the pentagon and each face that corresponds to the pyramid. So we're gonna have 6 faces. However, we're gonna have only 6 vertices, not 12. So the first option must be discarded. It cannot be a pyramid. The second option is that you have a prism. But a prism with 6 faces means that it's gonna have 4 faces around the cross section. And if I have 4, so it means that the cross section is going to be a rectangle. So my shape with 6 faces, a prism with 6 faces, is going to be a cuboid. Remember that a cuboid is just a rectangular prism. It says that you cannot hear. Man, if you cannot hear, maybe in YouTube you can hear better. Let's see. Okay, now I'm speaking again. Let me know if you can hear now. Thank you. So if you have a rectangular prism, it's going to be a cuboid. The cuboid is a shape that is a rectangular prism. And we have 6 faces, but in this case we have 1, 2, 3, 4 vertices here, and 1, 2, 3, and 4 vertices here. Is gonna have 8 vertices, so it's not gonna have 12. So, unfortunately, June is wrong. Okay, June is wrong. She's wrong. No, she's not correct. Why she's not correct? Because a shape with 6 faces will have 6 vertices. That is a pyramid, pentagonal pyramid. Or 8 vertices. That is a cuboid. Okay, now let's see the second question. The second question is Dylan states that he can create a pyramid with 6 faces and 9 vertices. Is he correct? Explain your reasoning. Obviously, in this answer, we already see it that it's no, because the pyramid that has 6 faces must have 6 vertices. Any pyramid with 6 faces would have or will have 6 vertices. Okay, pyramids, the number of faces of pyramids are going to be the same as the number of vertices. So this is how it works. This is how it works. Just to remember the people that are in Instagram that I'm in YouTube now. I'm also in YouTube. I'm also in YouTube. Okay, so in this case, we're going to have that 6 vertices. The number of faces are going to be equal to the number of faces. The number of vertices is equal to the number of faces in a pyramid. So this is going to happen. So he's not going to be correct. Okay, next question says, circle the correct statements. I'm going to circle the correct statements. I'm just going to test whether these statements are correct or not. And I'm going to show which statements are, if they are correct or not, why they are correct or not. A pentagonal pyramid has 5 faces. This is going to be false. We already see it. We already see it that if you create a pyramid with a pentagonal pyramid, it's gonna have a base of 5 sides, and each side is gonna have a new face. So it's gonna have 5 faces to create a pyramid. 5 faces, and the other face is going to be the base. So it's gonna have 6 faces. So it's going to be false. False. Okay. Hey, you know, I'm having problems with my pad today. Come on, pad. Okay, we know that it's false already. False. Okay, it's gonna have 6 faces. A cone has no vertices. No, a cone has 1 vertex, because a cone is a circle. Here we have a vertex that we can call it the apex as well, but it's a vertex, it's a point. So it's gonna have 1 vertex. False. A triangular prism has 4 rectangular faces and 2 triangular faces. Triangular prism, it will be cross section that is a triangle joined by rectangle. So I'm gonna have 1, 2, and 3 faces, 3 lateral faces. And here I'm gonna have 1 and 2 triangular faces. So it's gonna have 5 faces. It's not going to have 4 rectangular faces, but 3 rectangular faces. And finally, a rectangular prism has 10 vertices and 6 faces. We already observed that the rectangular prism, that is the same as a cuboid, the cuboid is gonna have 8 vertices and 6 faces. So it's already corrected. This correct, circle the correct statement. So they were all the statements were wrong. Now let's go to the next part, that is surface area of cuboids. We want to find the surface area of a cuboid with the following dimensions. I'm not if you're talking about the homework, this is not the homework. This is the formative assignment. I'm doing the formative assignment. I'm not doing the homework. Okay. Now we're going to see how to convert measurements, all measurements to meters. I need to convert this measurement into meters, this measurement into meters. I'm going to use the conversion factor. So I need to convert 8,700 millimeters into meters. So I know that 1,000 millimeters is 1 meter. I'm just going to simplify, and I'm gonna get I'm just need to divide 8,700 divided 1,000. Remember that if you divide by a power of 10, you need to move the decimal point. Decimal point is here. I need to move it 3 times to the left. 1, 2, and 3. So I'm gonna get 8.7. So the answer is going to be 8.7 meters. And in the second one, I have 230 centimeters. So 230 centimeters, I'm going to multiply by 1 meter, that is 100 centimeters. Simplify the units, and now I need to divide by 100, 230 divided by 100. And to perform this division, I just need to move the decimal point twice to the left. So I'm going to move it twice to the left. 1 and 2. So it's gonna get 2.30 meters. Or 2.3 meters. Now, I already have the 3 measurements, 8.7 meters, 2.3 meters. The height is 1.1 meters. I don't need to convert it. And I need to calculate the surface area. So even that here is not asking you to do the net, it will be good if you identify how is the net. And after you identify how is the net, you can calculate the area. So imagine that the net is going to be like made by rectangles. I'm going to do like a net, a sketch of the net, a brief sketch of the net. Okay, made by rectangles. And I know that one measure, let's say this measure is going to be, okay, I'm going to rewrite it, but in a way that we can see that it's a cuboid. Like I'm going to do my net, my sketch of the net, I'm gonna do it like in a way that we can see. Okay, could be something like this. Like we can see that it's completely different each side. Okay, something like this. So in this case, we can say that, for example, this side, this is like the shortest side, that it will be 1.1. This one is going to be 1.1 meters. This one, that is like the longest that we're using, this one is going to be 8.7 meters. You know, this one, that is this one as well. And finally this here, I'm going to tell that is 2.3 meters. Okay, so I already have different values of my net. So I have 6 rectangles to calculate. I'm going to put them in green. So this is rectangle 1, rectangle 2, rectangle 3, 4, 5, and 6. And I'm going to calculate the area of each rectangle, you know? Simple as this. This is how to calculate the net. Now, for example, rectangle 1 and rectangle 5 are going to measure the same. And it's going to be just the area it's going to be 2.3 times 1.1. 2.3 meters times 1.1 meters. So the area will be meters squared. And the area 2 and the area 6 are going to be the same. 2 and 6 are going to measure the same. That is going to be 8.7 meters this side times 2.3. 8.7 meters times 2.3 meters squared, because I multiply meters times meters. And finally, I'm gonna get rectangle 3 and rectangle 4. Both are going to measure the same area. A is going to be 1.1, that is this side. This side is 1.1 meters times 8.7 meters square. Now observe that what I'm doing is just getting pairs of dimensions to calculate the surface area. So I'm using by pairs the dimensions to calculate the surface area. And remember that I have two rectangles, so I need to, and this answer must be multiplied by 2 to get the total area. So I need to multiply this area by 2, this area by 2, and this area by 2. Now, this is just a process of multiplying. So you can just operate, multiply. Now, this is 1.1. So the answer here will be like multiplying by 11. Okay, they're asking me if in the exam I'm going to show conversion factors. Not the usual conversion factors. So in an exam you must know that 100 centimeters is 1 meter, that 1000 millimeters is 1 meter, that 1000 kilometers is 1000 meters is 1 kilometer, that 10,000 meters is square meters is an hectare, things like this. Now more difficult conversion factors may be given in an exam. Okay. Now I'm going to multiply these numbers. 2.3 times 1.1. This is going to be 253, and I have to put 2 decimal points. 2.53 square meters. Here this multiplication I must do it like in another place, and 1.1 times 8.7. I better do it in another place as well. So I'm going to multiply in another place very quickly. So 8.7 times 2.3, 21, 2, 3 times 8, 24, and 2, 26. 2 times 7 is 14. 2 times 8 is 16, and 1, 17. And now add 1, 6, and 4, 10. Oh my god, my pen is not working as in the way I want it. 6 plus 4, 10. Come on, man. 6 plus 4, 10. 7 and 3, another 10. Okay, I'm sorry. I just got busted with my pen. Come on, pen. Need you to work. Give me a minute. Help me. Let me see if I can fix it. I think I need to buy new batteries for this thing. Okay, my pen left me. Okay, at least you know the idea of how to get the area. The surface area. That is multiplying here. So I'm gonna get, come on, 10, 10 here. Oh god, help me, computer. Okay, people, I need to do it by hand and tell you the answer because it's not working my system right now. So let's get a paper to multiply 8.7 times 2.3. If you did it, it will be excellent if you already did it. But I'm going to do it here. So 8.3 times 8 is 8.7 times 2.3 Um, 1, 10, 7 and 3, 10, 2, 20.01. 20.01. That's the answer. What is it? 20.01 square meters. And here 1.1 times 8.7. I'm gonna try to do it here if possible, if it lets me. 8.7 times 1.1. I prefer to do it in this way because, okay, it's easier to do it, but oh god, actually this is just an addition, right? So 7, 8 and 7, 15, 1, 8 and 1, 9. 956, it says here. I just need to move 2 decimal points, 9.57. So this is going to be 9.57. Now, to get the surface area, no, it's not mandatory to use conversion factor, but it's important that you try to work on it, because in more difficult conversions, you must gonna require it. So this is more like, maybe for metric units, it's not difficult to do it, but for if it gets complicated with cubics, square units, cubic units, so it's better that you use the conversion factor. Okay, now what I need to do to get the surface area, I already have the area of each rectangle. What I need to do to get the surface area is to multiply each area by 2, because I got the area of 1, the area of 2 and the area of 3, so I need to multiply by 2 and add them. Now the problem is that I'm having issues here with my pen. So that this is, I'm so sorry. So I'm going to multiply this area by 2. Okay, so I'm going to multiply it by 2 to get the surface area. But I'm sorry, it's been difficult for me with this pad. Today my computer decided to leave me away, to leave me alone. So I'm going to multiply by 2 the area. So 2 times the area, and then here the addition. Total area. Okay, I'm sorry if it looks so messy, but this happens when your pad leaves you on your own good. Like when you're working in your iPad and your iPad tells you, I'm sorry, I'm not gonna work anymore. Okay, so I'm going to multiply this area by 2. 2 times 3, 6. 2 times 5, 10. 1, 2 times 2, 4, and 1 is 5, so this is 5.06 square meters. This is going to be 2 times 1, 2, 2 times 0, 0, 0, 40.02 square meters. And finally it's going to be 2 times 7 is going to be 14, 2 times 5, 10, and 1, 11, 2 times 9, 18, and 1, 19. And you just need to add these 4 measurements, these 3 measurements in meters squares. So I'm gonna get 6 and 4, 10, and 2, 12, 1 and 1, 2, 5 plus 9 is going to be 14. Come on, Pat. 14, and here 4, 5, and 6. 64.22 square meters. That will be the total area of the shape. Observe 8 times 2 should be around 20, yeah. 1.1, Okay, yeah, it seems correct. It seems correct, the area. 64.4. I'm just show how to calculate the surface area in square meters. So just remember that you can assemble the net. The net always is gonna have this form that I'm circling here. And this net, I'm just going to assemble the net. Look at that the area of rectangle 1 and rectangle 5 is going to be the same, like I put it here. Rectangle 4 and rectangle 3 is going to be the same, like I put it here. And rectangle 2 and rectangle 6 is going to be the same as is here. But if you observe, now you can do the net, okay? But if you observe, what we're doing is just using the dimensions in pairs, get the area of these two dimensions, times 2, because we have two equal rectangles, or two congruent rectangles, and then add them. This is how you get the surface area in square meters. Okay, now it says convert the surface area to hectares. 1 hectare is okay, this is wrong. It's 10,000 square meters. I'm sorry, this conversion factor is wrong. 10,000 square meters. So I have that is 64.22 square meters. So the hectare, 1 hectare equals 10,000 square meters. So I just need to divide, to simplify the square meters to get my result. Okay. Oh people, I'm so sorry that today my pad left me. Today my pad decided not to work. So I just need to move the decimal point 4 places to the left. Move the decimal point 4 places to the left. 1, 2, 3, 4. So here will be a decimal point. Okay, so the answer is going to be, what happened? 0.006422 hectares. Okay, I'm going to end this session with something about volume. I'm going to an exercise of volume of cuboids, but I'm going to a volume of a compound shape. Let's say that you have this compound shape. Okay, now I have this compound shape and I want to get the volume of this compound shape. When you have compound shapes, what you need to do is just divide your compound shape into different shapes. I mean cuboids. So I'm going to divide this compound shape into 2 cuboids. And look at the first cuboid. Could be, for example, this cuboid. Look, I'm going to draw the cuboid here. So let's say that this is cuboid A. And this is going to be cuboid B. So I'm going to get the volume of this shape that is compound. And to get the shape of this, the volume of this compound shape, I just need to get volume of A, volume of B, or volume 1, volume 2, and then total volume. That is just the addition of both volumes. Okay, so I'm gonna get volume A. Volume A will be the dimensions of volume A will be this, the height is 11 centimeters, times the width is going to be this, that if this is 15 and this is 20, so it's going to be 5 centimeters. And the length, that it must be this side here, that is 6 centimeters. So times 6 centimeters. You just need to multiply. 6 times 5 is 30. 30 times 11 is 330 cubic centimeters. And B, volume of B. So volume of B will be this shape here. The length is going to be 15 centimeters times the width will be 6 centimeters times, and the height will be 4 centimeters. We can multiply 6 times 15. 6 times 15 is 90. 90 times 4, 360 cubic centimeters. 360 cubic centimeters. So I just need to add both volumes. When you have the volume of 2 cuboids, add the third volume. That is going to be 330 cubic centimeters plus 360 cubic centimeters. No, you don't have to multiply in order, because remember that multiplication is commutative. So as you're multiplying 3 terms, you can multiply in the order you want. You're going to get the same answer. So there's no problem in the order you use. 33 plus 36 is going to be 69. So this is 690 cubic centimeters. Okay, if you multiply 11 times 5, then times 6 is going to give you 330. If you multiply 6 times 5, then times 11, it's going to give you the same answer. If you multiply 11 times 6, then times 5, it's going to give you the same answer. Multiplication is commutative. Okay, and that's it. I'm sorry that my pad didn't work like quite well as I expected. Now we just observed 3 different things in this 30 minutes. The first thing is to understand how faces and vertices are related in some 3D shapes. For example, in pyramids, the number of faces must be equal to the number of vertices. For example, a rectangular prism is the same as a cuboid. We observe how to calculate the surface area of a cuboid by doing the net. You can do the net, or you just try to identify the rule to multiply to get each area to get it, and then finding the solution. And finally, we observe how to calculate the volume of compound shapes using cuboids. In this case, remember that the volume of a cuboid is multiplying the 3 dimensions, length, width, and height. Identify it, divide your compound shape in 2 or 3 or 5 cuboids, doesn't matter how many, but divide it in cuboids, and multiply the dimensions to get added. And this is everything for today. I don't know if there are more questions for the people that are in the chat right now. If there is any question, let me know right now, because I'm about to leave. And if there are no more questions, hope that this video helps you to understand topics of geometry, to understand how to get the volume of cuboids, how to get the surface area of cuboids, how to work with 3D shapes, and see you in the next video. Bye bye. Have a nice day. See you. Bye bye for the people of Instagram. How to stop here?